So welcome to this very special edition of Friends of Tracking. We have a really special guest here. We have Hugo Bordegoni, who works for a company or founded a company called Skillcorner, who are looking at broadcast tracking data. So data from football matches live from TV footage. I think if I put this gallery view on, then we'll be able to see both of us at the same time. So welcome, Hugo.
Hello, David. Really nice to be here with you.
Yeah, so Hugo is going to get on to one of the most exciting things is that Skillcorner are going to release a data set for open usage so that you can hone your tracking skills. And that's what we're all about here on Friends of Tracking. But first of all, I thought I'd just ask a few questions because I think I first heard about Skillcorner and talked to you maybe 2 years ago or a year and a half ago or something. And then I just described you then as like two guys with a laptop in a cafe somewhere, but everything seems to have developed really fast. So I thought maybe if you could just tell us a bit of a history of how you got into this area and how it's gone.
Yeah, okay, perfect. So indeed, we started small. We started about 5 years ago. So we were actually just two guys with the laptop, just two sports and specifically soccer fans with the laptop. I have a data science and engineering background. So yeah, the idea was let's get some of the things that happen in artificial intelligence and computer vision to the sports industry. So computer vision actually exists in the sports industry for quite some time, but still all the things that we can see since maybe 2012 with autonomous driving or it has a lot of impact in a lot of the industry, but not much into the sports industry. So that's why and how we started. So that was 5 years ago. So basically, we were tech guys collecting data out of video, as you said, out of broadcast video.
And so did you have a background in computer vision before that? Then was that your...
Yeah, but only academic. Actually, I was just finishing my master's thesis on computer vision 5 years ago. And yes, that so I was computer vision, machine learning lover and sports lover. So that was a good combination for me. And that's kind of the thing for all the teams here at Skillcorner. So we started 5 years ago, and after starting collecting the data, the question was, okay, but who is going to be using this data? You know, Friends of Tracking wasn't alive at this time, and yeah, not a lot of people are able to handle large amount of tracking data. So what do you do with the tracking data? We actually started with working with the betting industry. And actually it's just recent that we start talking with a lot of clubs and start working with many of them, and specifically Liverpool with the first clubs we announced 1 year ago.
Yeah, that was very exciting because, I mean, everybody knows we've had Will Spearman on Friends of Tracking before talking about his work, and everyone knows that Liverpool are sort of leading the way in this type of research. And so tell me a little bit, I don't know how much you can tell me, but tell me a little bit about how that collaboration came about.
Yeah, I cannot say too much. You'll have to ask Will, but definitely it's a great first client to have. So the thing is, you know, all these clubs, especially in Premier League, they have access to tracking data for quite some time now, and they are skilled to using the tracking data. So all the Premier League teams have access to all the Premier League matches tracking data. So they are quite happy with it. The quality is really good, and you don't need broadcast tracking data on your matches if you already have optical tracking data. But when it comes to player recruitment, you have nothing except on Premier League. You have no tracking data at all. So that's where tracking data out of the broadcast comes into the picture.
Yeah, because that's the main problem for them. So they have that, and I think every team has that problem that they've got for their own league. But if they're looking to sign someone from Bundesliga, if Liverpool are looking for someone in Bundesliga or La Liga, they don't have access to that data. and that's
Yeah,
where you come
exactly.
in.
They have a lot of event data. You know, there is a lot of different event data providers that are able to provide event data on many leagues, but you never have the right tracking data to put in front of this event data.
Why the betting industry interested in tracking data?
Actually, yes, we started with the betting industry. It was not really a betting product. It was more fan engagement products.
Okay.
So I'll show a quick demo of what we're doing with them. So it's not really about betting. However, I really think like tracking data can help model probability, you know, everything about expected possession value or these kind of things. And I think this is kind of between the performance business, but also the betting industry. So there are some links between these industries.
Good. Okay. Well, I'll let you. You've got a presentation, so you can share your screen and tell us a little bit about what you've been doing, and also how data will become available.
Yeah. Okay. Great. So do you see my screen now?
I see your screen. That's perfect.
Okay. Perfect. Yes, a few words on Skillcorner. I already told it, but we're specialists in computer vision and machine learning, and we put these skills in the sports industry and only soccer at the moment to collect broadcast tracking data. That's a slide that you may have already seen. That's one from Jan van Aeren. And the thing is, you know, you have event data. Event data is highly available. So you can have it from different providers in many leagues. But you don't have all the information with event data. You only have like one player at a time and the different position of the ball and what's happening. You have like the high level picture, but you don't have a lot of granularity. Whereas tracking data, you have all the position of all the players and the ball, so you have much more granularity and much more context around what's happening, but it's not highly available, as we said. And that's the challenge that broadcast tracking data is trying to solve. So yeah, broadcast tracking data, it's not to replace the optical tracking data that exists with, you know, 12 cameras on the stadiums that guys like Second Spectrum, Stats, or Karen collects. So it's more complementary to these approaches, but the goal here is to have a wide coverage. So on the right, that's the list of the leagues that we're covering right now. So that's 25 leagues. And we'll probably cover more than 40 leagues by the end of this season. Second thing that you can have with broadcast tracking, it's live. You can get access to the broadcast feed in live, and you can collect the data in live. That's also possible with optical tracking system. However, it's much more complicated to handle the 16 feeds in live and do the processing live. And yeah, the last point, it's also about scale. So we've handled more than 10,000 matches to date. By the end of the season, will be around 20 to 25,000. So I think that's kind of the biggest tracking data database in any sport, or at least soccer. Yeah, just a quick demo of what does it mean. So that's a typical broadcast feed, and on this you need to detect the players. So that's the box you see around the players. Then there is two colors, so that's the team classification. Then you can see the lines in red. So that's what we call the homography. So the homography is to try to get the calibration of the camera. So as you know, with the broadcast, the camera is moving, and you need to know the parameter of the camera at each frame, at each time of the video. That's the homography calibration. And finally, you can see the player name. So that's the player recognition part of the process. And yeah, you can see the ball detection as well. So all these different algorithms are chained and happen one after the other to finally be able to collect the tracking data, which is, as you know, the XY coordinates of the players, the ball. We also have the Z coordinate for the ball, and the referee as well.
So just to clarify, you first find the pitch outline. So you first find the markings on the pitch, which are very constant. You then find the players, and you then, after that, you find the numbers, is it?
Yeah, so you actually do, you can do player detection or geomography at the same time, so because you don't need the one for the other. So you have to do both. Then from these two steps, you're able to localize all your detection on the pitch, so get the XY coordinates, but you still don't know who are the players. And then you track the players along their trajectories to have multiple images of the same players, which will make it more easy to recognize them. And then you do the player recognition.
And is the player recognition mainly based on the number on their jersey, or is it also based on features of the, like long curly hair and the color of the player and things like this?
Yeah, actually both. What's really important, actually, at least in our system, is it's completely unsupervised. So if you're familiar with machine learning, you have supervised learning and unsupervised learning, but we're collecting data on maybe 30,000 players, and we don't want to have a specific model, a specific training set for all these players in our database. And it will have to change every time they change from jersey, they change from hair color, or they change their boots, for instance. So this is not how it works. So the only reference that we get is the jersey number. However, the algorithms learn during the match to recognize each player. So it basically build a representation of each player, which will help when the number is not visible. As you see here, like no number at all are visible. However, we are able to do the player recognition.
Okay, so you give it, so first the algorithm tries to find the numbers on the jerseys at one point, then it tries to reverse, or then it tries to learn the player features based, given it knows the numbers.
Exactly. Yeah.
Okay. Well, that's quite impressive, because I mean, when the numbers are there, they have their backs turned. So they have their back. They must have their back turned when the numbers are there, and then it can keep a track of the. Yeah, tell me something more about how this works. Or
I won't show too much things technical, but yes, you're right. But actually, as we are tracking the players across the frames, the players are sometimes they're back in front of the cameras, but sometimes they will make a turn, and you'll be able to see them in all their different directions. So that's what makes it possible to then recognize them when you don't see the jersey number.
But you don't tell it that that's what it's going to, the algorithm, that's what it's going to do. That's what you mean by it's totally unsupervised. You're tracking objects. Okay, so you've already tracked the objects. And
so basically we have a neural network that learns how to differentiate players between them, and it doesn't need to know which player it is. It is just able to say, okay, these two players are probably the same one, or these two players are too different to be the same player.
Yeah, I got it. Good, really interesting. And I couldn't help but, sorry, now I'm just asking questions, but there seem to be no errors in your thing. Maybe you're going to come back to this with errors, but what's the error rate like for something like this?
Yeah, so on the player recognition side, out of all the data that we're delivering, actually 95% of the identity of the players are correct.
Okay.
So it means 5% are either missing or incorrect. On the missing, sometimes we know, like, okay, that's a Lyon player, but we're not sure about which one it is. So we'll just say, okay, that's a Lyon player. or sometimes we'll provide an identity, but it won't be correct. And it's actually really important to be aware of that. So our data is not manually checked and corrected like what's being done with the official tracking data provider in every league. We handle too many games to be able to manually go on each error and correct it manually. So that's actually not how we work. We just accept the errors that we have, and we believe we're just working on the algorithms to make it smaller and smaller. So now it's about 95 to 96%, and hopefully it will go to 97 and then maybe 98%, but I don't expect it to be 100% anytime.
Okay. Now you're going to give some reasons why it's difficult. So.
Yeah, exactly. So one thing about camera calibration, so that's the free picture we see. So the first one on the top, it's small here, but you can see that even though it's a Champions League match, so best optic quality in the world, however, you have a lot of distortion. And if you don't correct the optical distortion, you may end up with like 2 meters of error at the touchline at the end, which may be an issue depending on what you're doing with the tracking data. For instance, if you're computing speed or then acceleration, it's definitely an issue. On the second image, you can see a lot of smoke, and that's a real challenge to be able to detect the lines. Even for humans, sometimes it's quite complicated to see it. It also happens when you have a lot of sun and shadow in the same image. And last one is about Bournemouth Stadium, and it's not only about Bournemouth, obviously, but just all the smaller stadiums are a lot more challenging for us. So if you go to Premiership in Scotland, for instance, you have really small stadiums, and however, we have to be able to collect data in these stadiums as well. So that's change. Other subjects a lot challenging as well is ball tracking. We only have one point of view, but the ball position can be in 3 dimensions. So normally, if you want to detect a player in a thing in an object in 3 dimensions, you would use triangulation. But for that, you need multiple angle view. We don't have that. We only have one angle, and we still need to find the ball in 3 dimensions. So actually, we actually have like a neural network that learn a physics model to find the most probable position of the ball given the position on the image, and that's really tricky. We already talked a lot about player recognition, so I won't go with that again. And the last one is we're delivering our data live, and that's a big challenge because you cannot put a lot of processing power in live. You cannot spend like 10 hours to collect the data on one match. You need to do it live and with small latency, so you cannot really use the future to be good at a specific time. Okay. Okay, yes, this illustration just shows one track of our tracking data in red versus the unofficial tracking data provider in blue. So we can see that it's actually quite close to the true trajectory are close. But what's important here is now you can see the blue is moving, but the red is not. And that's one thing with broadcast tracking data. That's one limitation that you need to be aware when you use this data. It's you're limited to what's visible on the broadcast. So sometimes the broadcast just, even if the game is moving, sometimes the broadcast will show a close-up view or will show a replay, and you don't have any data there. So it won't be available in our data as well. And sometimes it's still a wide shot view, but you only see like 12 players. So you're missing 10 players in the broadcast. So that's the limitation that we have. And yes, second thing, as I said, everything is fully automatized. So there's no manual intervention in the process. And yes, that's it.
think this must have been when clubs are deciding if they're going to work with you. I imagine this is exactly what they do. They take their own league, they overlay your data on their matches, and they
Yeah,
work out the accuracy from that. They use that as a ground truth.
exactly. So there are two validation that they do. So the first one is to make sure that when we have some data, it's accurate enough. So that's the first thing. And the second thing is to see, okay, what does it mean to that they get data out of the broadcast? What do I miss? And am I okay, depending on the application that I want to do, am I okay to lose this piece of information? And that's a real work that we're conducting with the clubs to understand what's their application and can we solve it with broadcast tracking data.
Yeah.
Yes, let's talk a bit about the main purpose why we are here now. So we're really happy to be open sourcing a data set of broadcast tracking data. We believe that's the first initiative in the industry to open source this kind of data. So we actually pick out of the 5 top leagues, we pick the matches between the first one, the champion, and the runners-up from last season. So yes, that's these not 10 matches because France was stopped because of the COVID. So that's 9 matches. So this is already available, and we'll put the URL on Twitter so that people can access it.
Yeah. I mean, this is really exciting. This is, as you say, there is some tracking data available, but this is the first time for this level of football where it's easy to watch the videos, and you can probably find some stream or some available match footage for these results for these matches. And I think this will be really useful, and there'll be lots of people. What's the motivation for you in releasing this type of data?
Yeah, so the first one definitely is, as you do, try to increase the knowledge in the sports analytics community and give some proper materials so that people can build things, build tools out of the data, and maybe we'll say, okay, that's crazy good. We need to do something with this kind of work. So the second thing is about raising awareness on broadcast tracking data and what's the application and what you can do with that, so that our client will be aware of that. So that will help us on a commercial way. And the third thing is actually same thing on the commercial point of view. That's a good way to share some sample data with our clients so that they can get used to the formatting and get.
So you want to see lots of people working with this data, showing different things that you can do, and sharing it online as well afterwards.
Yeah,
that's the dream scenario here.
Definitely. We're really, we are building some applications ourselves. Some of our clients are building some application on their side. However, I'm really curious to see what will the community come up with this kind of data and what they can build with that. And yeah, I think it can be really positive.
Yeah, and those of you who are doing the mathematical modeling of football course with me just now, you will be using this data in your final project exercises, or at least part of them. So for us, I think it's a perfect timing for the release of this.
Great. Yeah, just really quick on the data. The documentation is available on GitHub, so people will be able to know that. Real quick, there is 2 different files. So one is about the lineup of the match, where you get all the players with their number, name, etc., but also the trackable object. And the trackable object is the link that will help knowing the identity of each player from the tracking data. And the second file is the tracking data. So we're collecting the tracking data at 10 frames per second. So it's delivered at 10 frames per second. And for each frame of the video, you have like a period identifier, whether it's a first period or second period. a timestamp showing exactly the timestamp, so it's frame accurate. So this timestamp is pretty accurate. And then you have possession key. So that's not really tracking data, but that's something we're including as well, which tells which player or which team has the ball, and it can be known when the ball is out of play. So as well, this information is not retrieved from event data, it's collected automatically out of the tracking data. So it's not 100% accurate as well. And finally, a data key where you have all the tracking data. But all this information can be found in the GitHub. Okay, and now I'll talk a little bit about application and what we are doing on our own with the tracking data. And hopefully people will find 20 more applications to do with this. So as we said, we're providing data for teams, for the betting industry, and for media as well. So the first thing we talked, David, was about what do we do with the betting industry. And I said it was about fan engagement. So actually we built this visualization in 2 dimensions that shows the position of the players visible on the broadcast, and the sports betting operators can integrate this visualization in live into the sports book. So whenever they cannot show the live stream of the match, they can show this visualization instead.
Can I just ask I mean, there's an interesting question here. What about if you started putting like Kevin De Bruyne's picture on there, and but you know, and also a Raheem Sterling picture on another player? At what point does it actually become the match footage?
Yeah, you're right. We think like there's some boundaries we must not cross.
Yeah, I can see that.
This is definitely one. So it's just data. It's just really basic data we're collecting out of the video, and that we're putting in good visual. That's all.
Yeah, oh, that's interesting.
Yes, these 2 visuals are more static things. So that's on the top. That's the different ball position during like 15 minutes of a specific game. And if you take the average position of the ball, you get like a sense of the domination, which is sometimes different from the possession information. So this metric can also be interesting, especially for fans. And on the bottom, it's a classic heat map that you can build out of the tracking data. So that's something we're used to seeing, especially for fans. And you can also build it for broadcast tracking data. And there's actually sometimes there can be a little bias using broadcast tracking data, especially if you look at the positioning of the goalkeepers, because when goalkeepers are visible on the broadcast, they're often near their goal line because they're probably defending. Whereas, you know, when your team is attacking and you're a goalkeeper, you are sometimes really far from your goal, but we never see that in the broadcast. So there might be some bias. And if you're using the data, you need to be aware of the bias that can be in the data. Yes, really important topic for us currently is what physical data. So as you know, physical data is like the primary use case that arrived with the tracking data. So at first, when the tracking data was first available, it was all about physical data. So what was the distance covered by my player, at which intensity, how many sprints did, and what was the max speed of my players. So when we arrived with broadcast tracking data, our first question was, okay, but is it possible to actually get this information, but on the broadcast? Like, you know, we're seeing the players maybe 50 to 60% of the time. are we able to collect the full total distance covered during the match, even when we don't see the players? And actually, we've worked a lot on extrapolating between what we're seeing on the pitch. So maybe the players have run 6 kilometers when it's visible on the broadcast, to 90 minutes values where maybe he has run 10 kilometers. And we've built some extrapolation machine learning algorithms to do this work. And actually, we show that it's working quite fine. And we have really small level of errors, especially when you don't look at the data on one specific match, but you look at 5 matches, 10 matches, 20 matches, which is what interests you when you're looking at player recruitments. So a lot of information can be found on our Medium, and a lot of data on comparing some leagues between each others, comparing some teams, comparing some players. On the top right, for instance, you can see the fastest player in European football. And obviously Mbappe is the fastest.
That's interesting. So yeah, I mean, I think actually people who've been watching Friends of Tracking's videos will probably not be quite as aware as they should be. And that's partly our bias in what we do in analysis, is this is the most common thing that clubs want to know about players, rather than maybe some of the fancier things like pitch control and passing probabilities and expected possession values. How fast can they run, and how often can they get up to those top speeds?
Yeah, definitely. And you know, they already have a lot of data for their training session. They put some GPS or LPS, and they get this physical data for their own match. Often there is this optical tracking system, so they already have a lot of data on their own players. But now when it comes to player recruitment, if you're a Premier League team and you are looking at a really good players in Eredivisie, for instance, you need to know, and clubs always ask us this question: does he have the leg to play in the Premier League? Okay, he's crazy good in Eredivisie, but will he cope with the intensity of the Premier League? And that's never sure. And this data can help you assess this.
Okay, and it's not just a myth that the Premier League is physically tougher than the other leagues. It's actually I'm maybe a bit critical of the axes here, which range between 51 and 60, and 20.2 and 20.5. I don't know. I can't quite see them, but there is a statistical difference between the leagues.
Yeah, definitely. So of course the margin are not big between top players in the world. You know, we're talking about maybe the 800 or 1,000 best players in the world. So the margin won't be super big. It's like the same thing if you're looking at the 100 meters in athleticism. If you plot Usain Bolt and another sprinter in between 0 and 10 seconds, everyone will be on the same line. But actually there's a big difference, and that's what we're showing. And if you look at the blog post in Medium, there are more information on the differences.
That's interesting.
And definitely Premier League is the strongest league in the world.
So you think Messi won't be any good in the Premier League then if he moves there?
I think Messi doesn't even need to run. He's just too good. That's for all the other players. Yes, that's another application. That's something we did with Laurie Show repository on pitch control. So it was meant for full tracking data, but we showed that that's actually possible to get some decent results with broadcast tracking data. So you need to handle things well, especially at the boundaries. Otherwise, when a player pop in, it will change completely the pitch control model. But if you do things smartly, looking at the future and the past, then you can actually get really good model of pitch control. So actually for everything that you're used to doing with full tracking data, there's probably a solution to make it work with broadcast tracking data. But there's always something to do. There's always some adaptation to do and some limitation to be aware of.
Can you, sorry to ask you to do this, but can you go back and redo that whole thing without the clip playing? Because that is going to be copyright cut by...
Without the what?
Without the clip playing. So just say what you said, but don't play say something about the pressing example.
Oh, okay.
But maybe take two frames or something, because we're going to YouTube have also got automated detection algorithms, so they're going to catch us out here. So just just say that again. Sorry.
Yes, so from the tracking data, that's possible with broadcast tracking. That's also possible with any kind of tracking data. You can compute some pressing score for each defensive player. And so here we are showing some pressing score for fans that we put as augmented reality layer on the broadcast. But actually the goal is not really about that. For teams, it's mostly useful to match tracking data with event data. And once you've synchronized the two different feeds, you can look at each event and get the pressing intensity for each event and report it in your event data to increase the amount of context that you get on all your events.
I'm sure this stuff would be lovely on a TV broadcast or something like that, automated tracking of. Yeah, I really like this.
Yeah, hopefully.
Whether it really measures pressing, I'm not completely convinced, but it seems to do something.
Yes, that's what I was talking about. So tracking event data is great on its own. Tracking data is great on its own, but the best thing you can do is synchronize tracking data with event data and add more context on each event. For now, we're only open sourcing some tracking data, and we won't be open sourcing event data because we're not collecting event data. However, we'll probably go and open source some library that helps users match tracking data with event data, so that if they have their own access to some event data, they will be able to match it with our tracking data.
Yeah, I think that's very helpful. I think that's one of the. You still need event data just now in order to do analysis, because although the tracking data is better and better, it doesn't quite get everything that you need. So that's really good.
Yeah. Oh, and that's the last thing. As I'm actually really excited to show you. That's the first time I show it outside of Skillcorner. That's around full tracking data. So actually from the broadcast tracking data that we currently have, we're trying to, that's a work in progress, that's a research project, it's not a product yet, but we're trying to output the most probable position of the 22 players to let you work as if it was official tracking data from your official provider. And this is what it looks like. So in light green, it's actually the field of view of the broadcast. So that's what is actually visible. And the rest is completely extrapolated out of the training data that we feed it.
So the training data, you have the broadcast data for the whole, sorry, you have the full data, you train it up, and then it learns the positions, because it was quite good there in the switch over. It did get them right.
Yeah, exactly. So you never know, at least if you don't see a full picture of the pitch, you never know if it's the actual position of the players. But if I didn't show you the light green area, I think you will have a lot of issues finding which player are actually visible and which player are not. So yes, we believe that that could be a good way for clubs to apply directly what they've built with official tracking data. Yeah, and that's it for the presentation.
Okay. thanks very much. That was really, really fantastic. I think you have to switch off your share screen there.
Sorry.
It's okay.
That's okay.
Oh, that's really fantastic. What's next for you then? It's getting more leagues, or it's developing applications based on this, or what's the priority?
Yeah, so indeed, the short-term priority is increasing our coverage. We currently have 25 leagues, which is great. However, when you talk with Eastern clubs with smaller budget, for instance, they're not scouting in the same leagues, so they want some other leagues. So we need to adapt our algorithms to work with worse optic quality, worse broadcast quality. So that's the main challenge right now. But it's also about what we do, which application we do with the tracking data. Physical data is now fully covered and people are really happy with our physical data. However, we believe physical data is just one part of what you can build with tracking data. So some clubs are happy just buying our tracking data and building everything on top of it. We believe that we can help them in this transition by open sourcing some tooling that will make it easier for them. So that's the second challenge. That's also why we're open sourcing this data. That's why we will open source more tools to make it easier for people to get started with our data.
Yeah, that's really nice. One question I get a lot is from, actually particularly from fathers of 13-year-olds. They want a system where they can put up a camera, film their kids playing football, and manage to like track them and give them feedback. My normal answer is they should just calm down and let them play football. But is that a feasible thing for your type of system to do, or what would be the limitations there?
Yeah, that's a really decent question that always come up to us. We're currently trying to expand our coverage, so we will be working with lower quality video feeds. At the moment, our idea is to stop at professional level. However, that's always something that we keep in some part of our mind. Maybe we'll be able to go to amateur level in a second time. But you know, tracking data is quite complicated to handle, at least for now, and not a lot of people are skilled to handle it and do some really useful things. So if you make it available for U15, who will use this 1 million data point per match and do something sensible with it?
That's so okay. So one last question. I mean, we've said something about this, but for all the people who are going to go and take away and work on this data, is there one particular dream application that you'd like to see from people, or do you just want them to freely express themselves and come with different ideas?
Yes. Everything's open. I think, you know, the work that Laurie has done with formation analysis could be quite interesting with broadcast tracking data.
Yeah,
because we could apply it across a lot of leagues. So I think that's definitely something of interest. And the fact that it comes from broadcast is a challenge, but shouldn't be an issue that you can't overcome.
Yeah.
So that's one topic. I think everything related to expected possession value is also completely meaningful, and I'd be really interesting to see what people can come up on this subject. You know, we don't have the time to work on all the possible application internally, so it's really good to see people working with it outside of Skillcorner.
Cool. Okay, that's great. Thanks very much, Hugo. And
Yes.
really, well, thanks both for your time and taking the time and doing this, and for making this this data set available. And hopefully we're going to see lots of applications of this, and maybe we'll do another video in a month or so showcasing a few of these. I hope so anyway. But
yeah, definitely. Thanks a lot for the invitation. We're really happy to be part of it. And yeah, the data is already available, but we'll open source more tools and we'll let you know once it's available to make it easy for people to get started.
yeah, great. Thanks.
Thank you.